Alrighty, how are you doing? Let's talk radians. Page 190 is where I'm looking here. And here's what I'm going to talk about. Converting angle measures from degrees to radians and recognizing trig ratios to complete reference triangles. My plan is to do this part first, maybe even separate videos to then show you this. I'm curious, when I get to talk to you, this is something you already knew. So that's 190. Let's go over here to 191. Okay? On page 191. Well, here we go. We got ourselves our cycle. And it's all about taking the fact that we can say something about degrees and now talk about it in radians. So like radians is just a different unit for measuring everything that we've ever used to measure in degrees. So angles, basically. We know a circle is 360 degrees. Do we know what it is in terms of radians? Okay. So suppose angle, there's a symbol we're going to use. Get used to that. That's the new X for angles, okay? It's in standard position. Standard position, we learned about that last unit. And is formed by one complete counterclockwise rotation. Counterclockwise, we know that means positive. What's the measure of the angle? Angle. All the way around, counterclockwise. All the way around. That's 360. Counterclockwise, that's positive. Boom. 360. Okay? What's the measure of this in radians? Give an exact answer. So whether this is something you know from your past or not, 360 is all the way around in degrees. In radians, radians always involve pi. In this case, 1 time all the way around is 2 pi radians. So 2 pi radians is 1 time all the way around. And we're going to use that to kind of get to the point where we can go between the two. Okay? So I've already come up with that. This is something that they were in Springboard trying to lead you to from an activity on number 1. See how we're on number 2. Maybe we'll talk about that while I'm there, but for the video's purposes, I'm just starting you know this information, which means we can also just write it here, just to put it in a different place. So 360 degrees is the same as 2 pi radians in terms of the measure itself. Let's break this down even further. That's 1 time all the way around a circle. What is 1 degree? If 360 of them are 2 pi, what's 1 of them? Well, let's create a fraction just like last time. So 1 degree, that's like 1/360th of a time all the way around the circle. So instead of going all the way around 360, 1 degree would just be going 1/360th. So let's take 1/360th of 2 pi. How do we do that? 1 over 360 times 2 pi. If I'm doing this, it's like I'm finding out what 1/360th of this is, which will tell me what 1 degree is. When we go and we do this kind of stuff, converting between them, we're going to usually leave them as fractions, whether those fractions are improper or not. So always remember when you have a fraction times anything, if the anything does not have a bottom, it just goes to the top. So what's 1 times 2 pi? This becomes 2 pi over 360. Let's leave the pi, but let's simplify the 2 over 360. 2 goes into 2 once. 2 goes into 360. Well, you know what half of 360 is. It's 180. So pi over 180 is what I'm putting right here. Okay? We can think backwards now. Okay, radian. I want 1 radian. I don't want all the way around. All the way around is 2 pi radians. I just want 1 radian. So, same thing. Let's say I want 1 2-pieth of an entire rotation. So times that fraction by 360. Same thing, I got a fraction. I got to think if it's not a fraction, so I can just times the top. We're looking at 360 over 2 pi. Hey, 2 goes into 2 twice. 2 goes into 360 180 times. We're looking at 180 over pi. 1 radian is the same as 180 over pi degrees. These 1-to-1 sort of ratios here are how we convert. To go from degrees to radians, you times by this. To go from radians to degrees, you times by this. And then I'll show you, just because, again, we want these fractions that are improper, so to say, but definitely always simplified. Okay? So let's convert. I'll convert to, and then I'm going to ask you to convert this one on your own. 45 degrees. We're going from degrees to radians. Degrees to radians. That's when I times by pi over 1/80th. So let's times this by pi. Put it over 180. I've pretty much already written the fraction, so the question just becomes, how do I simplify 45 and 180? Well, you can do it all you want. You can start with, oh, 5 goes into both of them. Oh, something else. Here's what I know. 45, that's half of 90. 90 goes into 180 twice. If that goes into 90 twice, that means that 45 goes into 45 once. Keep the pi. 45 goes into 180 4 times. Boom. Pi fourths. Now here's one where we'll get to see what I'm talking about with the improper fraction. So again, it's in degrees. I'm going to times it by this to get it into radians. Here we go. I basically have already written it where 2 tens on the top of the pi. We know the pi's staying. The question is just, what's something that goes into 210, in this case negative 210, that also goes into 180? Think through that all you want. I'm simplifying it and saying, okay, there's a 21 and an 18. Well, I know something that goes into both of those, and that something is 3. So since there's a 0 at the end, we could say 30 goes into both of them. Negative 210, 3 goes into 21 7 times. 3 goes into 18 6 times. This is where, keep it like that. Let's make this be 7. Let's make the bottom be 6. Since nothing goes into both 7 and 6, that's how we're going to keep it. We're not going to turn it into 1 and 1/6 with the pi on top. No. We're going to keep it like that. Okay? You should pause this right now and convert 15 degrees to radians. Do so right now because I'm going to give the answer in 3, 2, 1. You did the same thing as before. Times it by pi over 180. In this case, you're looking for something that goes into 15 and 180. Maybe you're testing stuff in your calculator. Oh, 3 goes into them both. Oh, 5 goes into them both. Hey, you know what else goes into them both? 15. 15 goes into 15, of course, once. If you divide 180 by 15, you'll get 12. This is pi twelfths. Okay? Same thing, just other direction. Instead of going from degrees to radians, now let's go from radians to degrees. Boom. Same fraction, but I'm putting the 180 on top this time. Another way to think of this is that you're dividing away the pi, which is like getting rid of the radians, and that's what we're trying to do, right? We're trying to turn it into degrees. So I start with pi over 2. I times it by what it said. Now this time there's another fraction, so let's talk about what happens when we have that. What happens when we have that is we times cross the top, we times cross the bottom. So pi times 180 times 2 over pi. I can tell you already, they're going to be a single term, both with a pi. The pi's are going to cancel, so it's just going to become 180 over 2. Well, I know what 180 divided by 2 is. Cut it in half, it's 90 degrees. All right, let's go again. Another fraction here. Times it by 180 over pi. Once again, the pi's are going to cancel. The pi's will pretty much always cancel when you're getting rid of radians. So then what am I left with? 2 times 180. That's 360. 3. Type it, figure it out. 3 goes into, well, I'm going to get rid of this 1, 0. 3 goes into 36. Well, it goes into 30 10 times and then 6 twice, so 12 times. But there's this 0 too. So it's actually 120 degrees. Okay? At this point, why don't you try the 4? The pi's not going to cancel this time, but we're still going to come up with a number that's going to work nicely. Try it, and I'll show you the answer in 3, 2, 1. All right, we've got this. We times it 180 over pi. We go and we do that. 4 times 180. That ends up being 720. We still got the pi on the bottom. So that's kind of a weird thing to do. Let's see what this comes out to be in our calculator. So 720 divided by pi. That comes out to be 229.1. 229.1. Well, the question here was to the nearest degree. Well, I guess to the nearest degree. So if this is just 0.1, would round down. So this is roughly, not exactly, but roughly 229 degrees. Okay. All right, so that's how we're doing that. There's other things they can ask you. They can ask you to name the quadrant or axis where the terminal side will go. Remember what terminal side means. If you're in standard position, this is the initial side. The point always goes in the middle, and then this, place it in. Sometimes it's up here, sometimes it's down here. That's the terminal side. So where will the terminal side be in each of these? Oh, so it's just random radian values. Well, let's create a graph over here and talk about radians. If I start here, 0 is still 0. 0 degrees is the same as 0 radians. So 0 radians. And then we said if we go all the way around, it would be 2 pi. We've already said that. Okay? Well, if I went all the way around to get to 2 pi, then what if I only went halfway around? Well, that's pretty easy. What's half of 2 pi? Pi. Okay? What if I only went half of that? I only went half of pi. What would that come out to be? Well, just write it like that. Write it as pi half. Just think of it as like 1/2 with the pi on top. Which is why you should also write this as, instead of 2 halves, just write it as 1. But then this would be 3 halves, right? So write it as 3 halves. 3 pi over 2, aka 1/2. So 1/2 of pi, 1 pi, 1.5 pi, 2 pi. We're just going to try to figure out these ones down here, do they each fit in between these ones, these ones, these ones, these ones, or maybe they're actually exactly on some of them. Okay, so here we go. First one, pi halves. So 1/5 pi. Well, let's think about that. Here's a half pi. Here's 0. Here's 1. Is 1/5 less than a half or more than a half? Because it's got the pi in it. So it's like I'm ignoring the pi, but I'm not paying attention to it. And then I'm just thinking about this as a half. 1/5, definitely less than a half. Okay? If we're doing fifths, a half would be like 2.5 fifths, which is not. It's less than that. We're going to end up here. Remember what quadrant this is? Quadrant 1. This first one is in quadrant 1. How about this one? I know that's B, but I'm going down to C. How about this one? 3 pi halves. I come over here. 3 pi, well that's this. Okay, it's not in any quadrant. It is in fact on the negative y-axis. That can be one of the answers. Okay, let's try another one. This time it's negative. So remember what negative means. Negative means instead of starting out counterclockwise, we actually go clockwise. So in this case, when we're doing it, 1.5 is the same as negative a half. Okay, let's try. So negative 4/7. Negative 4/7. Okay. If I'm in terms of sevenths, what's half of 7? 3.5. So if I went from here to here, it's negative because I'm coming down. This would be 3.5 sevenths. But I'm supposed to go negative 4. So I'm going to go just a little bit past this. What quadrant does that put me in? This is quadrant 1. This is quadrant 2. This is quadrant 3. This is quadrant 4. So that puts me in quadrant 4 because, again, negative 3.5 sevenths. A little bit further to get me to negative 4 sevenths. This ends up in quadrant 3. Why don't you try to figure out where this one ends up? Think it out. Think about that it's positive. Think about what it says. Pause it now because I'm just going to give you the answer in 3, 2, 1. Again, hopefully you've tried this on your own. You're not just copying down what I've said on this particular one. You're actually thinking it out. Positive. So counterclockwise. 11/8. Okay, well that's more than 1. So I already know I'm going to be past this. Question is, am I in here or am I in here? Well, this, if I did reduce it, would be like 1 3/8 pi. 3/8. Is that more or less than 1.5? Less. So it wouldn't quite get that far. If it did, it would have been 1 4/8, but it's not. It's 1 3/8. It's going to also be in quadrant 3. All right, let's flip the page. Let's see what they got up their sleeve for us to do next. Next up is another thing standard position. Okay, we're going to write the radian measure just based on that. So here we go, 1/4 of a complete clockwise rotation. Okay. Sorry about that. 1/4 a complete clockwise. Okay, clockwise means coming down. Because again, we're starting here, the point there, we're just coming this way. So 1/4, 1/4, half, 3/4, 4/4. Basically, we're coming to here. Okay. So how far is that? Well, I know it's negative 90 degrees. So I could write negative 90 and then convert the whole thing. Or I could just remember what I wrote on the last page. In this case, over here would have been pi. So this is a pi half. Okay, since I'm going clockwise down, it's negative. This is negative pi half radians. Let's look at 2/3 of a complete counterclockwise rotation. Complete. Okay, that would have been going from here all the way to here, but this is 2/3. 2/3? Oh yeah, how do I do 2/3? Well, let's think about what I just said. If I had gone all the way, that would be 2 pi. But I don't want to go all the way. How much of all the way do I want to go? 2/3 of it. Same thing. I got 2 pi now. We were doing it before, it was just a pi, but I can take that 2 pi and times it by the top. So now we have 4 pi thirds. Should I simplify it? No. Keep it like that. Okay? This is counterclockwise, so it stays positive. Okay? You, by the way, should try to stay positive also. Oh, these videos. Alright, the third one. 1 3/4 counterclockwise rotation. Counterclockwise. So 1. Well, I already know what that is. That's 2 pi. I'm going to add that to something else later. And 3/4. Okay, I already did my 1, so here's 1/4, 2/4, 3/4. Okay, how much is that? We already talked about it. It's 3 pi halves. Okay, so what I'm looking at here is I'm looking at basically 1, 2, 3 and a half pi radians. How do I write 3 and a half pi radians? Well, let's keep 2 on the bottom. Okay. If I keep 2 on the bottom, pi on the top, I'm trying to get to 3 and a half. Okay, 3 and a half with a 2 on the bottom. Well, 1, if the 2 is on the bottom, would be 2 halves, right? So 2 would be 4 halves. 3 would be 6 halves, and I need to get that half. I've already got the 6 halves, so I just need another half, so that's 7. This is 7 pi halves. Okay? If you get this, then you can do the next thing we're going to talk about, which the next thing we're trying to talk about is coterminal. Aha, back. Okay. Explain how to find angles coterminal to a given angle measure in radians. Well, we talked about it before that degrees is plus or minus 360, because remember what coterminal means. Coterminal means in standard position, if this ends here, well, so does this. Okay, they end in the same place, assuming that they're starting in the same place. So if you're here, then you want the next one, you want to go all the way around, and all the way around, and all the way around. Well, all the way around is 360. Well, we're not doing degrees. Let's shade this away. We're doing radians. Radians, you plus or minus an entire rotation, which is 2 pi. I wish it was that simple. The hardest part about this is going to be, what does 2 mean when I have fractions? Well, it's not that hard. Let's just figure it out. All right, instructions. One angle in the standard position, blah, that's positive, and one that's negative. Easy. We don't even have to keep it between any numbers right now. Just one positive one, one negative one. I've got a positive one. Let's make another positive one. Remember, I'm supposed to add 2 pi. Here's the rules with adding, though, since this is a fraction. If you're going to add with a fraction, the bottoms have to be the same. How can I convert 2 pi into something over 5? Well, the pi stays. And again, just think of it as 2. If I'm doing fifths, what should be up here for the fraction to simplify to a 2? Well, 2, 5. If this was 5 fifths, that would be 1. If it was 10/5, that would be 2. That's what I'm actually adding. Now I'm taking this and I'm adding it to this. I have 3 pi-fifths and I have 10 pi-fifths. That's a total of 13 pi-fifths. Boom. Positive 1 complete. Now let's do a negative 1. Let's subtract this time. I already know that I'm going to subtract 10/5. So I'm going to go back to the original. The original was 3 pi-fifths. Now I'm going to subtract 10 pi-fifths. Hopefully that'll get me into the negatives. It will. Had 3 pi's on the top, took away 10 of them. I'm into the negatives. -7. With addition and subtraction, the bottom just stays the same. Boom. -7 pi over 5. Let's do another one. You're welcome to try without me. But once again, it's already negative. Let's add 2 pi. 2 pi. In this case, what would that be? Well, it's supposed to be in thirds. So I've got to convert 2 pi into how many thirds? 6. Okay. So now these are the two things I'm adding, and in a second I'll subtract. I've got negative 2 pi's, and I'm adding 6 more. That gives me up to 4 pi's. The bottom just stays the same. And boom, I've got my positive 1. Now I need to get a negative 1 just like I did up here. Okay? To get this negative 1. Whereas over here I was adding 6 pi. Now I'm going to take again the original and subtract 6 pi thirds. If I already had 2 negatives and I take away 6 more, I'm down to -8. Everything else stays the same. Hey, that's negative. That was the goal. Positive, negative, boom. That's how you do that. We can do the exact same thing here we were doing there, but now instead of asking for a positive and a negative, they're asking for something between 0 and 2 pi. So just keep doing it until you get something that would simplify to being between those two things. Okay? 13 is obviously too many, so we got to take away 2 at a time. Now it's nice that this was not a fraction. So like if I take away 2 pi right now, I'm down to 11 pi. Nope, that's still not between these. Let's take away another 2. Now I'm down to 9 pi. Okay? Since there's patterns in reputation, if I'm going from 13 to 11 to 9, I notice that I'm just going to keep going down by odd numbers. So the next thing I would go down to would be 7 pi. But I'm going to skip and just cut to the chase. Started with odd, took away 2, next odd, took away 2, next odd, took away 2, next odd. So what am I going to end up at? 1 pi, or just pi radians. Is that between 0 and 2 pi? Absolutely. Let's do it again. This time it's negative. Okay, so we're not going to take away 2 pi. This time we're going to add 2 pi. Oh, but here we are again with fifths. So I need to convert this. This is actually what over 5? Well, it's 2. So what can I create over 5 so they would simplify to 2? 10. We already talked about that one up above. So really what I'm doing is I'm adding 10 pi to whatever's on the top here now that I've matched the bottoms. So we know the bottom is going to be 5. We know there's going to be a pi. If there used to be -32 of them, and I added 10, now there's -22 of them. Okay? Again, I know the pattern in repetition here. It's changing by 10. So if I was at -22, I could then go to -12. -2. Okay, what does this look like? -12 pi fifth. Well, that's like 2, and oh, it's over 2, so it's not between these. Plus, it's between 0 and 2 pi, so it's supposed to get to the point where it's positive. So if I keep going with that, okay? And then the next one is -2 pi fifths. Oh, I know I'm close now. I just got to add, hopefully only once more, to this. Add the 10 pi half, or 10 pi fifths. And what is -2 of them plus 10 of them? +8 of them. You keep everything else the same. Is this between 0 and 2? Well, if it was 2, it would be 10 fifths. It's not. If it was less than 0, it would be negative. It's not. That, bolder than the rest, is your final answer. At this point, you've got part of what you're ready to do on your assignment, which you should check the exact numbers for, but that would be on page 196. So go there now and see if there's anything you could do. Maybe there's not. Maybe there's some things we gotta further explain in a separate video.